In a world dominated by the internet and the relentless growth of the digital economy, the data center holds a key role. The shrinking of silicon transistor, known as Moore's law, since 2004 has no longer simply increased the processor's clock frequency. By 2006, microarchitecture optimization started to level off, leaving only a small percentage increase in performance per processor generation. Such limitations and the advent of the big data era has led to the formation of two key trajectories for cloud computing. Trajectory 1, scale up, to increase the size of a single computer, managed by a single operating system. Trajectory 2, scale out, to use many computers, each managed by an individual operating system. Trajectory 1 first moved to multi-core processors when clock frequency could no longer be increased. However, providing double the cores more than doubles the cost. Design limited to only a few cores from silicon scaling and limited number of memory interfaces means as you add more cores, the performance of each core reduces. Trajectory 1 therefore moved to multi-socket, connecting multiple multi-core processors together, allowing application software to continue to scale up. However, although each processor shares its cores and memory interfaces, the deeper memory hierarchies and non-unified access latencies limit scaling to only a few sockets. The second trajectory is more straightforward. It uses multiple independent computers, with software balancing the load of an application across each computer. However, clusters do not use the biggest multi-socket scale-out computers, since these do not scale efficiently for a distributed application in terms of power and total aggregate performance. All data centers must balance the commercial demands of web-scale-sized clusters against the resource demands of scale-up applications, while maximizing the efficient utilization of all resources. Various constraints have led to data centers using only average-sized computers, a compromise that is suboptimal both for scale-up and scale-out scenarios, by scale-up solutions wasting resources when asked to scale out, and scale-out solutions limiting the resources for scale-up applications. To summarize, the modern cloud data center comprises of large capital investments across hardware and software and tries to accommodate both scale-up and scale-out concepts using average-sized computers while serving thousands of users with diverse operational and service requirements. User-facing applications like web and social networking demand low response latency to provide high levels of user satisfaction and map well to scale out. Contrarily, simulation and big data analytics need substantial computational resources and map well to scale-up platforms. Despite their proliferation, cloud computing has grown without effective mechanisms to manage their vast amounts of resources efficiently, leading to severe resource waste while limiting their applicability to large classes of critical applications that pose non-moderate average resource demands. Since January 2017, the EU Horizon 2020 funded project 732366 ACTiCLOUD has been investigating the effective activation of cloud resources for large databases and investigating techniques for scalability and elastic provisioning of cloud resources. ACTiCLOUD adopts two leading hardware platforms covering the best of both scale-up and scale-out. These platforms enable ACTiCLOUD to scale today's constrained commodity-targeted software to the increased availability of resources of scale-up, while also offering the benefits of better power efficiency and compute density of scale-out. Looking at the project as a whole, ACTiCLOUD uses the NumaScale platform in support of bigger applications, and the Kaleo platform to support more instances of an application. These hardware platforms are orchestrated using the on-app developed rack scale management of these heterogeneous platforms to enable cloud applications to extend over both the best of scale-out and the best of scale-up, the ACTiCLOUD platform. The University of Manchester is focused on the management of the increased resources available to Java applications, while the University of Umeå works to optimize the scheduling and scaling of the overall platform. To validate the ACTiCLOUD platform, 2 resource-demanding applications are used. Neo4j increases the scale-up support in their graph database, while the MonadDB's column store database embraces the horizontal scaling of scale-out. ICCS, besides being in charge of the overall project coordination, focuses on cloud resource management and works with Umeå University on the design and implementation of ACTiManager, a novel cloud manager that maximizes the use of resources for typical scale-up and scale-out scenarios. The objectives of the ACTiCLOUD project are to reduce the costly resource waste in today's clouds while providing the platform for a broader set of critical applications to move to the cloud by enabling the scalability of databases in the cloud. In conclusion, ACTiCLOUD enables a cloud provider to extend their support for both scale-up and scale-out hardware through a unified rack-scale orchestration and management platform, the ACTiCLOUD platform, and open up the full benefits and capability of a European technology-based cloud.